Hi guys, thanks a lot for this warm introduction. It's really cool. So I believe you can hear me well, and you hear myself, you see the presentation. So I will just start. Yeah, my name is Valentin Kononov. I'm full stack software developer, and I'm really started from a .NET and from C#. That's why it was really hard to me when I needed to start working on with the JavaScript. And years of trying that and working with in the different companies with the different applications and paradigms bring me to what I really would like to talk about today. I hope you will find it not just interesting, but kind of motivating to think about what happens with your code when you run it. So let's rock on and let's get started. So first of all, I'm not initially from Minsk, but I spent there the big amount of time, like 4 years, and I'm a big fan of GDG Minsk community, and I'm constantly participating in the GDG meetups organization. So this is a nice group of people trying to bring the community up and trying to share their great knowledges. And also, I was working with Angular a lot. For a while, and I'm a little bit part of the Angular Belarus and Angular Minsk communities. So if you're interested in that, try following them in Telegram or other sources. They usually have the meetups and stuff. And yeah, I'm working at Mapbox company at the moment. It's a really nice company, and you just mentioned that I'm working with Nest.js. I love Nest.js, and the project I'm working on here in this company is built atop of Nest.js. So it's really cool stuff and really cool experience, apart from mapping and other important opportunities. But let's get started. So I really wanted to interrupt a little bit, and if it was, for example, the live session, I would ask you to raise your hands or to try to answer questions. But we are not live, but still, who cares? Let's start with some questions. So first question would be, do you write code in JavaScript? And for the first glance, it's a really stupid question for the JS Poland conference, because, okay, come on, we all write code in TypeScript. But if you think, it's not so stupid, because the second question is, do you write code in TypeScript instead of JavaScript? And I would really like to know the statistics, like how many people work with the TypeScript rather than JavaScript. And apart from that, what kind of other languages do you use in your day-to-day programming life? Or, I don't know, maybe as a pet projects, or you want to learn, and actually why? Because all that moves me to the next question. If you learn other languages, is there something in JavaScript you miss, or you wanted to have there, but it's not there? And the last one which I'm asking myself nearly every day, what makes you happy when you write the code? So to understand a little bit more about all these questions and about the JavaScript, first we need to go a little bit into history, like how many? 25 years before. And do you remember this screenshot? If not, I will just remind. This is a screenshot of Netscape Navigator, which was one of the top and nearly the only one browsers in 1995. It was killed later by Internet Explorer, but the talk is not about that. The talk is about the times the web was pretty static. We already had HTML, but we didn't have any animation. We didn't have any reactivity. We could not push the button and see something happens. And that made some interesting companies like Netscape Navigator and some think about, okay, let's come up with some other language which will be easy to use, which will not be Java, because we already have Java. Come on, we don't need another Java. And it will be very easy without the classes and all the complicated stuff, so that designers can use it to add some interactivity to our nearly static web world. And it was written by Brendan Eich, the really interesting guy. The interesting fact is that he created the draft version of JavaScript in nearly 2 weeks. It was really fast task. And it turns out that this was the world's most misunderstood programming language that eventually has become the world's most popular programming language. If you don't believe that it is most popular, here's the Stack Overflow statistics from the previous year. It's on the top of that. It's on the top of everything. So, like it or not, we live in the world of JavaScript. So we need to know how to live with it. And that makes me trying to learn a couple of things in JavaScript. And when I was learning that, I noticed a lot of jokes about JS, and I really would like to show you a couple of ones. I believe everyone knows that this kind of expression, when you try to do mathematical expression with different type, will lead to some either correct answers or not correct answers. Like when you do the string plus number, the result is string, but the string minus number is correct number. And if you do the two mathematical operations at row, it's still correct code and it will be executed, but result will be kind of unpredictable. So what if we change and instead of just string, we use some object? It still will be executed and we will have the result which is correct from the JavaScript perspective. But with the minus, we will have the different result which is also correct from JavaScript perspective. So I believe you all remember this joke about the two books for $9.99 in total. So what is the solution? Why we came to this and why the JavaScript behaves like that? Because everything in JavaScript is an object, and with object you can do whatever you want. You can change the object, you can copy it, you can change some fields, and everything is dynamic. There is no classes, there are prototypes because of the same reason, so you can change it. And there is no real privacy. I believe everyone remembers that the underscores which we used to change what is private, what is not private. So all the things which are core stuff in JavaScript, they remain the same during the 25 years from the very beginning. And what is the answer? So actually, I came from a .NET, and when I first time tried to write something in JavaScript, I was I felt like someone took some really important instrument from me. I missed the compilation step. So I write something and I didn't have any chance to understand, is it okay or not? Is it working or not? But eventually the TypeScript came on the stage. And it was created by Microsoft in 2012. And it was object-oriented, strongly typed. It really helped the compilation step and it really made me happy. I believe you also remember this joke. When I was a junior software engineer, we made fun of it. But when you actually work with JavaScript, you so miss it. So the TypeScript come on the stage. And we all know that JavaScript is dynamic and weak. So in spite of that, TypeScript is strong and static. So I would think that it would solve all our problems. But would it? To understand why the TypeScript is so great in terms of the static types, in terms of the strongness and stuff, let's just remember who created that. And it was created by Anders Hellsberg, who also created the C# before, and who also created Delphi before, and Turbo Pascal for Borland company before. So you see, he brought nearly the same ideas to the TypeScript about the compilation, about the classes, about the solid feeling. You write something, you feel it's solid, it works. But is it? Okay, let's think a little bit about the case when you write the program in TypeScript. And you write this really small code like that. So you have some function which displays some field of object, like we'll have movie with the name Game of Thrones, and everything's fine. But what if at some day we understood that the word name is not a correct word for title? It has different meaning, and we change it. What happens? If we used any, nothing happens. It will be compiled and it will be the correct program from the TypeScript perspective, but we will see some undefined message somewhere. To get rid of it, we just need to use interfaces, and this will introduce us to the world of static types, to the strong thing of a TypeScript. And if we mess up right now, we will see the compilation error, which is absolutely great. Without even one run of the program, we know that something is wrong. Is there any other cases when we can mess up? So before we move to that, we're all a little bit lazy, and if we don't want really to not use any, there are some things like we can set up the special flag in our test config, no implicit any. And by that, the Typescript compiler will let us know if we will just create a variable without any type. But it's not all. We can also use no explicit any as an ESLint setting. And this is extremely great thing. It will force us not to use any at all. So I really suggest to use it. And in case if you really need any somewhere, you can just use the ignore comment. Okay, is there any other cases when you can mess up? Of course, yes. And the very famous case is when you try to access the name, the field of an object by its name, by the string name. And the same, if there is no such field, you will just see undefined somewhere. But TypeScript gives you the opportunity to get rid of it. You can just use the operator key off to check that this string is really represents the name of the object. Okay. Everything is fine on the compilation with that, and it's okay. When you work with the TypeScript, the work looks like that. You write the TypeScript code, it gets compiled. During the compilation, you have some static code analysis, type checks, linters, and all the other interesting stuff. But what's next? At the end of the day, you will have JavaScript. And when it will run in a Node.js or in browser, you have a JavaScript. And there is no types in JavaScript. So the TypeScript, and the whole reason I'm talking about that is that the TypeScript gives you the sense of feeling safe, the sense of that you're doing things right. But is it? Let's think about it. Here's the sample of small class with some small function for multiply of two numbers in a TypeScript. When you compile it in JavaScript, you see there is no such types. Who cares, you would say. If I will mess up in a TypeScript code, I will see the compilation error. And it's really like that. You will see just an error in the console if you will use the incorrect arguments. But, so what? What could possibly go wrong with all of that? You have the compilation and you have all the checks. Why these guys keep talking about it? Because there are cases when not just you uses your code. For example, if you write the library, or if you write the backend services, or anything where the code or its functions will be used by someone else. And if it's used by someone else, you do not control it. And that person could use any. Let's take a look at this example. So this is correct example, everything is fine. But what if the person who calls your service would wrap the argument with any? TypeScript will say, okay, this is compilable code, but result will be unpredictable. For some cases it will be okay, for some cases it will be not okay. And the same like in the JavaScript jokes, you will not know about it. You will just see the incorrect behavior, but you will not know what's happening actually. So who cares? Once again, any is our first and most important enemy here. The next, literal property access. But again, it's all about our code. We also can have the pure JavaScript for some reason where there is no checks. And the most important thing, if we write a library or a framework which is used by someone else, and someone else could drop the call to your functions with any or with stuff like that. And also, last but not least, the backend and front-end request. So someone can try to attack, someone can send you unexpected request or response, and it happens. So what? When I was thinking about it, I started to think about solutions. And there are a lot of actual solutions here. So first, and the really obvious solution is to validate everything. And this is a perfectly working solution for validation of requests and response when you talk about the server and the client communication. So you can validate You can validate your request, try response, and everything is fine. Also, you can test, and you can create tests for everything. So, for example, you can create tests for every backend endpoint with any kind of type of parameters to see what happens. But, it's a huge amount of work. And also, you can check manually, which is even bigger amount of work. So, actually, too lazy to do the 100% of all of that. But, of course, validation really makes sense. So, by manual check, I also started to think to write some manual check. So, for example, imagine the case we have the super critically important function multiply, which accepts two numbers, and I need to be absolutely sure that I receive exact numbers and not some strings, not some objects and stuff. So I can really write just a couple of if clauses where I will check the argument type. It will be a working example, but it's a huge boilerplate actually. So can this check be made so simple that even my dog can understand it and can use it? And after that, I started to think about the incredible feature which exists only in TypeScript, which is decorators. And I implemented the sample with the type checking with the decorator. So I imagine that it could be like that. So you implement a function and you just put a small decorator without any parameters. The name is just really simple, like type it or something. And as a result, you have everything checked. And you will have error if someone will mess up with the type of input arguments for you. So how it can look from the inside, this decorator. So decorator is a function. You know that decorator is a function which will wrap around another function. And we will not get into so much details about the decorators in general right now, but the most important thing is that when you write a decorator, you should return a function which received a couple of arguments. And this function will be not called by you. It will be called by JavaScript runtime. I will show you later. And the core thing here is a descriptor. So when you write a decorator for a function, you get some kind of descriptor, which has the reference to initial function. So the function which is wrapped around by this particular decorator. So what you can do, you can store this function somewhere, and then you can perform all the type checks you needed. Like check that this argument is okay and this argument is okay, or maybe even the length of argument and stuff like that. Or maybe if you're too much concerned about the big numbers, you can check something else. And then, if everything is fine, you can just call by method.apply, you can just call the initial function. But if not, you can throw an exception. How it can look even deeper, so the type checking. And how we can even know that the argument should have this or that type. So the TypeScript gives us incredible feature, which is also a little bit optional. You need to turn it on, but usually it's turned on by default. In most projects like in Angular and stuff, it's reflect metadata. It's a separate library which is installed, which gives you a little bit package overhead, but it also gives you the capability to use the decorators and to use the benefits of metadata. So what is that? You can receive the different kind of metadata for function, for class, for field of class, and stuff like that. So for example, here I'm receiving the metadata for parameter types. And also, I have access to actual arguments, and I can use the actual type of keyword to receive the actual type. So I have everything I need. Actually, I have name of expected type, and I have actual type. I can just compare. And I can do it in runtime. So not in a compilation time when everything should be fine, but in a runtime where I don't know who calls my function and I don't know with what kind of argument. Even if it's any, I will know exact type and everything will be great. So with some except, of course, there is no perfectness in this world, and the reflect metadata does not reflect the types for arrays members. for array members, and it does not reflect types and names of interface. So if it is interface, you will just get the object, unfortunately. But still, the types like the classes, types like the number, string, array itself, and similar, like Boolean, date, will have the correct names, and you will be able to check it like this. So, okay, let's see how it works. So you implemented this multiply function, you put the type decorator. If you compile it in JavaScript, the call to this function will look like that. So before the actual code of this class, you will transpile it to JavaScript. You will have the call of decorate function, which is actually service function of a JavaScript runtime. And it puts the correct additional arguments. So it actually fills the demand for metadata. So this code is created by the compiler itself, and it will be persist in your bundle. So you see that for design parameters, we have the array of 2 numbers, which is carefully and actually reflects what we write in TypeScript code. So we have all the capabilities to check. So once again about the decorators, if you will need to implement something else. In decorator, you have access to target, which is instance of the object of the class where the decorator was put. You have the property name, which can be the name of a function or name of a field, and you have a descriptor, which has access to the function itself. It's for function decorators. Other decorators can look slightly different. And of course, there is some performance overhead. So usage of reflect metadata will give you some overhead, but it's minimal. And when I was talking about this thing with range of people from industry, some told me that, okay, it's a great idea, but you might not want to have it in production, but instead you might want to have it turned off or on in a development environment, in an active testing period, which is actually cool. So what I did, to prove my point, and to be better prepared to this presentation, I created the small NPM package, which is called TS Stronger Types. TS Stronger Types. So my mission here is to make the usage of TypeScript much stronger than it is right now, so that you can really rely on the code. It's something I miss all the time, but I really want to that the code make me happy, and I want to rely on that. So that's why I created that. It has a type decorator with everything I just described, and it has settings. So using environment variables or using the actual options, you can specify should it be turned off or on, how you should log errors. So it can be console log, or it can be anything you want, and some other things like should you throw or should you just log the error if there is some. So you can install it, you can check the documentation and stuff like that. So actually, if you will find issues, just let me know. The poor thing, again, I can check arrays, but I cannot verify the type of array member. Unfortunately, it's not possible right now, even in TypeScript 4. And the same goes for interfaces. So I guess it's also the reason of that is mostly because of the compatibility to the what we have in JavaScript. And of course, this talk and the article I wrote about this would not be full if I will not consider some options, some other alternatives. And there are a lot of them. So I picked just 3 ones. So the first and maybe one of the most comprehensive and impressive is IOTS. This is a library which allows you to construct the new kind of type. So instead of just implementing a class or interface, you construct type using the functions from this library. And all the checks goes inside. It's pretty cool, but the drawback is that if you work with existing project, you will need to rewrite the whole class ecosystem, which can be quite long. Another cool library is Superstruct. And it's much simpler. So you can use the regular types, so classes or interfaces, and you can use the validate incoming JSON, for example. And it will read the metadata, I guess, and will validate that incoming JSON is okay for this type. So pretty cool for certain cases. And the most important, I guess, and the most popular is the class validators. So you might hear about it if you are familiar with Nest.js, because the validation pipe for all the incoming requests of Nest.js is using this. If you and the usage of that is as simple as that. You create a class and you put the decorator for the class member. Like title should be a string, and rating should be int, maximum 10, and the mail should be email. And the validation of that can be done either manually by calling the function validate, and that's it, validate, and you put an object inside of it, and that's it. Or in Nest.js, you just turned on the validation pipe, and it's working. Of course, there are some cases when you should tweak it a little bit, but in most cases, it works pretty well. So, in other things, when I was sharing these ideas with other people in industry, a friend of mine who was working as a software developer, I don't know, like 40 years, told me about an interesting case. He told me that for some program, for some server-side API, he implemented a small attribute, or you can call it decorator, which he put on every function or every endpoint. And during a test, every function marked with this decorator was called with random parameters. So it can be a strange case, but just think about it. You put really zero efforts for testing of a function. You just put an attribute at top of that, and it's already tested does it fails or not. Of course, it doesn't test the business logic, but you can be sure that the test passed and all the arguments are correct. Correctly handled. So it's just genius. Think about it. So I think I'm coming to the end of my talk and presentation. I have like 3 minutes left. So if you will be interested, all the links are here in my slides. So there is a package. There is the article about that in my site. There is a presentation, and if you're interested in the code of decorator, just to dig deeper into it, to understand how it functions, to understand what the drawbacks, you can go to my GitHub, TS Runtime Checker, and try working it. So as a conclusion, and on my last slide, I want to talk about the several things. So first of all, my work with the TypeScript and JavaScript was about trying to understand, okay, what's next? So I've written this code, how it will be executed, who will work with it. So when you write code, think about the runtime. Do not make the TypeScript give you a sense that everything is fine. It will be fine if you will think well and if you will make it fine. The second step, make your code as predictable as you can. So make sure that it works in a predictable way. Test it and use types and validation wherever you can. And the most important thing, enjoy what you do and enjoy the well-written code. Try to make what you do to make you happy. Thanks a lot. I think I'm done with the presentation. The last little piece I want to mention that this amazing logo was created by my daughter, and I'm super proud that she did it for me and for this library for the testing purposes. So thanks a lot to my daughter Alice, and thanks a lot for JS Poland organizers. It's an honor to me to be part of that. Thank you.